Alright, I'm Daniel Kang.
I'm Ryan Wyatt.
And I'm Austin Hare, the cameraman, and we are from Mr. Olivo's 1A Calculus AB class. I'm here to explain to you chain rule and power rule when taking derivatives. So, hope you enjoy. Hi. We're first going to start out with the power rule. Now, the power rule, all these rules are easier ways to take derivatives than using the definition, and they can save you time once you become efficient at them. Alright, so here's the starting definition form of the power rule. D over d of x to the x to the nth is going to equal nx to the power of n minus 1. This basically just means that this rule states you take the function's power, you drop it and multiply it by make it a coefficient, and then you subtract the power by 1. We'll use a real example with numbers now. So d over d of x x to the fifth equals 5x minus 4. No, 5x to the fourth, sorry. As you can see, we took the power of the function, we made it a coefficient, and we subtracted the old exponent by 1. Alright, this time we're going to show you how this would apply when the function is a fraction. So, d over d of x (1 over x to the third) equals d over d of x x to the negative third. As you can see, this allows us to apply the power rule to this function. It allows us to put the negative third. Now we can do, this will equal negative 3x to the negative 4 which when simplified would equal negative 3 divided by x to the fourth. Last but not least, we're going to show you how you would use power rule when you have a square root. So, d over d of x equals the square root of x. I mean, not equals, square root of x. Alright, so in other words, this would mean d over d of x x to the 1/2. Now don't get confused here. This is just allowing us to implement the power rule into this problem. Alright, so this would then equal 1/2 x to the negative 1/2. Don't forget to simplify this though, so the final answer would be 1 divided by 2 to the square root of x. Overall, the power rule proves to be the most efficient and fastest way to take a derivative of functions like these, and will often be used in calculus. So make sure you know this because it helps a lot with taking derivatives.
Alright, this time we'll be going over power rule. And this time it will be 2x d over dx of 2x raised to the 2/3. And you just take the derivative of 2/3. As you can see, you just multiply the 2 by the 2/3. And now you have to subtract 1 from 2/3. Which equals a negative 1/3. So the answer is 4/3 x raised. Now you can simplify the answer even more, which equals 4 over cube root of x. There you go. That is the answer.
Alright, now here is power rule simplistically in depth. Let's say you're trying to take the derivative of x squared. So d over d of x of x squared. Now, make sure you multiply the 1 coefficient in front of the x times 2. And you get the 2 from the power in the original function. In addition, make sure you minus 1 from the power in order not to be confused. This is one of the key things that can make or break your grade on a calculus test. Last but not least, make sure you simplify as much as possible in order to get max points. And that's how you get the answer, 2x. That was the power rule in depth.
Now we're going to do a power rule problem that is more complex. You're going to take the derivative of x to the 5th plus 4x to the 4th minus 6x to the 3rd plus 2x squared plus 3x. It's just like a normal power rule problem, but you take each and separate it. So x fifth, you take the derivative of x to the 5th first. So you take your power, 5, multiply it by the coefficient of 1, x to the 4th, plus 4 times 4, 16, x to the 3rd. And then, because there's a negative in front of the 6, it would be a negative 18 because of the 6 multiplied by a 3. And then that would be x squared. Then you add the derivative of 2x squared, which is 4x. And then to finish it off, you would add the derivative of 3x, which is 3. And that would be your final answer. It's the same as a normal power rule, it's just more steps and more complex.
Hi, last but not least, we are here to explain chain rule. Now, chain rule can be defined as a formula for computing the derivative of composition of two or more functions. In other words, in mathematical terms, d over d of x of f of g of x equals f prime g of x times g prime of x. So this basically means you take the derivative using your other rules, let's say power rule, which you should know by now. Take that first, and then you multiply it by the inner function. Alright, so now we're going to use an example with numbers. Let's start out with d over x of 2x plus 5, all of it squared. So that will first we take the outer derivative. So drop the 2 down. Notice how we kept the inner function the same. Now we're going to multiply it by the derivative of the inner function. Last but not least, we simplify. Alright, now we're going to do a more complex problem. So, d over d of x of, let's say, 2x plus 5 all to the 7th. Now don't get confused here. It's the exact same. We're going to follow the same steps. So first we take the derivative of the outer function. Then we take the derivative of the inner function and multiply it by the first number we got. Alright, for this next problem, we're going to implement even more diverse rules in order to solve. So, d over d of x of 1/2 x plus 2 all to the 1/2. Alright, now this may look hard at first, but we're just going to start out with the first outer function. So we should get 1/2 x plus 2 to the negative 1/2. Now we take the derivative of the inner function and multiply it by the derivative of the outer function, which we end up getting as 1/2 is the inner function. Last but not least, we simplify. So we get 1/4 Alright, lastly, we have to simplify this one more step. Now, a common mistake that can be made here is that you leave it as 1/4 all divided by that. You got to make sure the 4 goes in the denominator as well, otherwise it will obviously be counted wrong.
This is the chain rule in depth. So we're going to start with d over d of x of 5 times 2x squared plus 5 all to the 4th power. So you take the derivative of the outer function. So you take the power, which is 4, and multiply that by the coefficient outside, which is 5, equaling 20. 20 multiplied by your parentheses again, and then you take your 4 minus 1 to get you a power of 3. And now you take the derivative of the inner function, or the numbers in the parentheses, which would be 4x plus 0, because the 5 derivative is just 0. And then from there, you simplify the outside of the function. So you would multiply your 20 by your 4x, equaling 80x, multiplied by your 2x squared plus 5. And that 2x squared plus 5 to the third. And that would be your final answer.
Alright, this time we're going to do a combination of power rule and chain rule. Alright, so here we'll have a problem d over d of x of 2x squared plus 3x, all raised to the fifth. Alright, we'll do what we did originally. First, take the derivative of the outer function, which equals 5 of 2x squared plus 3x, all raised to the fourth. Now, we are going to take the derivative of the inner function. And this time, we'll have to use a power rule, because the 2 and then we'll bring the 2 down, which equals 4x plus 3. Okay, and you just simplify. So that should equal 20x plus 15 times 2x squared plus 3x, all raised to the fourth. And that's it. Simple as that.
I'm Ryan Mai.
And I'm Daniel Kang.
And I'm Austin Hare. We are from Mr. Olivo's 1A calculus class, and we hope our explanation of chain rule and power rule will help you in his classes. Thank you.
Alright, good luck.
Good luck.